Hello everyone, welcome to my YouTube channel IndiaGATE. This is Nandani Sharma. In this session of Discrete and Engineering Mathematics, we talk about set relation, which is really important with respect to GATE. So, if you want new tricks, new tips for GATE, so please subscribe my channel and click on bell icon for all notification of my new videos. So, let's start. So, start from binary relation. A binary relation is defined as, let's set A and B. A binary relation from A to B is a subset of A Cartesian product of B. So, the relation is represented like A relate B if and only if A comma B is belong to R, and also it say that A not relate to B if and only if A comma B is not belong to R. Now move on. Next point is function as a relation. So a function is always a relation, but relation can be function or not, because a relation can be used to express a one-to-many relationship between the element of a set A and B, while a function represents relation exactly one element of B related to each element of A. Means f of A is equal to B, because here B is related to set A element small a. So we say that a function is always a relation, but a relation cannot be function or maybe function. Now move on. Very important subject point is that relation on a set. So a relation on a set A is a relation from A to A. So here our most important question is that how many relations are here on this set with an element. So answer is that a relation on a set A is a subset of A into A, means A represent an element. So A into an A element represent n into n element and n square subset. So we say that the set with an element has 2 to power of m subset. There are 2 to power of n square subset of A into n. Thus we say that here total number of relation is 2 to power of n square with an element. And another important point is that if total number of relation is greater than number of function, yes, because here total number of relation is 2 to power of n square and number of function is n to the power n. In the previous session we discussed about this. Okay, now move on. Next important point is that properties of relation. So here various properties of relation like reflexive, symmetric, antisymmetric, transitive and so on. So discuss one by one. First one is your reflexive relation. A relation R on a set A is called reflexive if A comma A belong to R. Every element A is belong to set A for all A, and A comma A is belong to R. Now move on. Next, symmetric relation. Symmetric relation are on a set called symmetric if B comma A is belong to R. Whenever A comma B is also belong to R for all A comma B is belong to set A. So it is precisely defined as for all A for all B, where A comma B is belong to R implies B comma A is belong to R. So it is called your symmetric relation. Now move on. Antisymmetric relation. A relation R on a set A such that for all A comma B is belong to set A if A comma B is belong to R and B comma A is belong to R. So we say that A is equal to B. So this is your antisymmetric relation. Precisely it is implies as for all A, for all B, where pair of A comma B is belong to R and pair of B comma A is belong to R is implies A is equal to B. Now main point is that the term symmetric and antisymmetric are not opposite because a relation can have both these properties or may lack both them. Now move on. Next property is that asymmetric relation. So asymmetric relation is a binary relation which is not a symmetric relation, or we say that in other word, a relation R on a set A is called asymmetric if B comma A order pair is not belong to R. Whenever A comma B is belong to R, for all A comma B is your subset of and belong to set A. So we precisely say that for all A, for all B, where A comma B is belong to R is implies negation of B comma A pair belong to R. Now move on. Next point is that a relation is asymmetric if and only if it is both asymmetric and irreflexive relation. And what is a irreflexive relation? So a relation R on a set A is irreflexive if for all A is belong to A, means order pair of A comma A is not belong to R. That is, R is irreflexive if no element in A is related to itself. So it is called your irreflexive, means for all A where A comma A is not belong to R is called your irreflexive relation. Now move on. Next point, transitive relation. A transitive relation R on a set A is called transitive if whenever order pair A comma B is belong to R and B comma C is belong to R, then we say that A comma C is your also belong to R for all A, B, C is belong to set A. So we, in short, we say that for all A, for all B and for all C, where order pair of A comma B is belong to R and B comma C is also belong to R. So this implies A comma C is also belong to R. Now move on. Very important questions which is asked in GATE with perspective of or properties of relation. So how many number of relation on there set with an element that is reflexive? So we say that there is 2 to the power of n into n minus 1, and also in perspective of symmetric we say that total number of relation is 2 to the power of n into n plus 1 by 2. So now move on. Next important relation, number of relation, is perspective of irreflexive, that 2 to the power of n minus 1, and reflexive and symmetric. So we say that total number of relation is 2 to the power of n into n minus 1 by 2. Now important point is that number of different relation from a set with a m element to a set with n element. So we say that total number of relation is your 2 to the power of mn. Now move on. Next important point is that combining relation. The combining relation is also say that composite relation. So let A be a relation from A to B and S is a relation from B to C. So composite of R and S is C as is equivalent to A comma C. means ordered pair of A comma C. So we say that it is follow as your transitive property. Let R is a relation on a set A. The power R of n, where n is 1 to 3 and so on, is defined as recursively by R dash is equal to R and R to power of n plus 1 is equal to R to power of n composed of R. So the relation R on set A is transitive if and only if R to power of n is subset of R for all n is equal to 1 to 3 and so on. Now move on, next property is your inverse relation. So inverse relation, set R be a relation from A set A to set B. A relation is inverse from B to A is denoted by R inverse. The set is ordered pair, yes, where B comma A is such that A comma B is belong to R. Now move on, complementary relation. The complementary relation R bar is the set of ordered pair where A comma B such A comma B is not belong to R, and in the inverse the A comma B is belong to R but inverse is represented as B comma A, but in the complementary relation it is represented as A comma B. So this is two main difference between inverse and complementary. Sometimes representing relation using matrix. Let R be a relation from A to B. The relation R can be represented by matrix means MR equal to Mij, where Mij is equal to 1 if AI comma Bij is belong to R, else 0 it is not belong to R. The matrix of a relation on a set which is square matrix can be used to determine whether certain properties are like reflexive, irreflexive, antisymmetric and symmetric. So a matrix is reflexive if and only if the main diagonal of matrix is equal to 1 and irreflexive when main diagonal of matrix is 0. A matrix relation R is symmetric if and only if matrix equal to transpose of matrix, and a matrix is antisymmetric when either Mij is equal 0 or Mji is 0, where I is not equal to j. Now important points are is MR1 union R2 is equal to MR1 join MR2. Second one is MR1 intersection MR2 is equal to MR1 meet MR2, and third is MS composite R is equal to MR XOR MR2. Whether the relation has a closure property of relation. So a closure property of relation is consist of three important properties. First one is reflexive, second is symmetric, and third one is your transitive property. So this is very easy. Concept is basis of the relation. Properties like reflexive is R union delta, where delta is represent your A comma A such that A is belong to set A. And second one is your symmetric. It is represent like R union R inverse, where R inverse is your B comma A such that A comma B is linked to R. And symmetric properties represent like transitive properties represent like connection of R star. So the connection of R star is consist of the ordered pair A comma B such that there are path length n from A to B in R, or we say that MR star is equal to MR join mr2 join mr3 join and so on, mrn times join, where n is the number of element in a matrix. Now move on. Next point is that equivalence relation. This is very important relation basis of the gate, because it is always asked the question from the equivalence relation. So if you know about the three properties of the equivalence relation is reflexive, symmetric and transitive, so it is called your equivalence relation. Two element a and b that are related by a equivalence relation are called equivalent. It is represented like a equivalent v. And here I hope you understand all the points. Thank you for watching.